Hello everyone. This is about part 3 of the lab over chapter 15. And this part is about buoyancy and the relationship between the buoyant force and the fluid density. You'll start by clicking here to download the simulation. This is the simulation page. You'll click on the Begin tab here. You'll keep the mass of the bottle 1000 grams, which is equivalent to 1 kilogram. 1 kilogram is 9.8 Newton. And you'll keep the bottle volume. This is the bottle. This is the object we are going to submerge in the fluid. We'll keep it at 500 milliliter volume. 500 milliliter is zero point 0.5 liter, and 0.5 liter is 0.5 decimeter cube. So it's basically equivalent to 5 times 10 to the negative 4 cubic meter, because decimeter cube is 10 to the negative 3 cubic meter. And now we are going to follow the table 3, which asks you to change the fluid identity to gasoline first, then crude oil, fresh water, and finally maple syrup. And each time we need to record the weight of the bottle in air. That's basically the force due to gravity, mg. And then when we submerge it in the liquid, we need to record the apparent weight of the bottle in the liquid. The apparent weight of the liquid will decrease due to the buoyant force that is opposing the force of gravity inside the fluid. And then we'll need to find the buoyant force. So I'm going to show you how to find each one of those 3 columns 3, 4, and 5. So to change the fluid identity to gasoline, we need just to click here on the fluid, and you'll see its identity will change until we reach gasoline. So that will be the gasoline. And then you'll have here the force sensor that measures the weight of that bottle. And this one is connected to a computer virtually. So when you click start here, you'll see down here the weight is recorded and it's in Newton. And then I'm going to go up here, and you can see as it's submerged in the liquid, the apparent weight will decrease, and the sensor will record how much the weight decreased. Of course, how much the apparent weight decreases is equal to the buoyant force. So let me reset it here, and I'll set it on a fluid that you're not going to see here, because the whole purpose here is for you to do the experiment. So I'm just going to change the fluid here to whatever value it is. So now you cannot see the fluid. I'll show you how to determine the weight of the bottle in air, the apparent weight in the liquid or the fluid, and how to calculate the buoyant force from the weight in the air and the apparent weight in the fluid. So I'll click start here. Now you can see here the bottle is still in air. So here the force sensor is measuring the weight in air, which is 9.8 Newton since the mass is 1 kilogram. And whenever it's completely submerged, as you see here, we reach stable value of the weight. This is the apparent weight here. The scale, the vertical axis here represent the force in Newton as read by this sensor, this force sensor. And it's a little bit below 10, which we expect. It's 9.8 Newton since the mass is 1 kilogram. Okay, 1000 grams is 1 kilogram. So 1 kilogram times 9.8 meter per second square will give us the weight of the bottle, which is 9.8 Newton, as shown here. Now, whenever we start submerging the bottle in the fluid, the apparent weight will drop until it's completely submerged, where the apparent weight will become constant. And this is the apparent weight in the fluid. And here we can see it's exactly lined up with the 5. So we can take it as 5 Newton. So this will be the apparent weight of that fluid. I did not reveal the fluid identity, but the purpose here is to show you how to determine the apparent weight and then how we can calculate the buoyant force. The buoyant force will be the difference between the weight of the bottle in air and the apparent weight of the bottle in the fluid whenever it's completely submerged. So it will be 9.8 Newton minus 5 Newton will give you around 4.8 Newton. The difference between 9.8 and 5 Newton is 4.8 Newton. So you'd go to the table here and basically you know that the weight of the bottle here will be always 9.8 Newton, no matter what's the liquid. Those values will be always 9.8. That's the weight in air, which will not change because we are using the same bottle, which has a mass of 1 kilogram, which will give you 9.8 Newton weight. And then you record whatever apparent weight you got from the graph that the simulation will reveal. And then you find the difference between the weight in air and the apparent weight, and this will be the buoyant force applied on the object. Recall that the buoyant force is opposing the direction of the weight, so that's the reason why the apparent weight will decrease by the amount equal to the buoyant force. Okay, so that's it for this video about how to conduct the experiment. In the next video, I will show you how to do the analysis of the data we have. Thank you.